Given that f of x equals x squared minus x plus 3 and g of x equals 2x minus 1, we need to figure out what the composition of the following function. So we want f composed with g of x, okay, and then g composed with f of x. So let's take a look at both of these. So example A, we have f composed with g of x. Okay, remember that just means we're substituting g of x into f. So this is the same as f of g of x. So now we can take our functions. G of x is 2x minus 1. Okay, so we want f of 2x minus 1. Okay. So that means everywhere in f that we see an x, we're going to now put 2x minus 1. So if we do that, f says x squared. Okay, so that means instead of x squared, we have 2x minus 1 squared minus x, which is 2x minus 1, plus 3. So now we can simplify this function. So we get 4x squared minus 4x plus 1. That's what we get when we take 2x squared minus 1 and square it. Minus 2x plus 1. Okay, we're subtracting a 2x and subtracting a negative 1x, and then finally plus 3. So now we can combine like terms. We have a negative 4x and a negative 2x, and then we have our constant terms that we can combine. So we end up with 4x squared minus 6x plus 5 is our final answer. So this is the new function f composed with g. So we can see that f composed with g is 4x squared minus 6x plus 5. So we've just created a new function out of these two functions. So let's look at example B, where now we have g composed with f. Okay, so the order does matter here. So this is saying now I want g, and my input is going to be f of x, g of f of x. Okay, so notice the switch in order here. So what that means is we have g of x squared minus x plus 3. Okay, so everywhere we see an x in function g, we're going to plug in x squared minus x minus 3. So g is 2x minus 1, so this becomes 2. My input is x squared minus x plus 3 minus 1. Okay, so now we can simplify that. We use the distributive property, and we get 2x squared minus 2x plus 6, and then we have our minus 1, which is equal to 2x squared minus 2, and then 6 minus 1 is 5. Okay, so the composition of g of f of x is 2x squared minus 2x, this should be an x down here, plus 5. Okay, so notice that the result is not the same. Okay, so order does matter when we're composing functions. They are not necessarily commutative. Okay, so f of g of x is not necessarily the same as g of f of x. So that's an important fact to remember, is that function composition is not commutative. So that means for us that order matters. Okay, so in general, it's not commutative. You might find functions where it doesn't matter whether you take f of g of x or g of f of x, that you end up with the same thing. But by and large, that is not true.